So goal definition is to really about writing down the different elements of our problems. So it's kind of like fill in the blanks where we have to answer different questions. It is really helpful for us to define clearly at an early stage the different elements of our problem. It's especially important to do so in early stage because it will allow us to have a better idea, a clearer idea about the problem that we have and how we can solve it. If we define the different elements of our problem, then we will have a better idea on what type of data we need. Let's try to go one by one. The first question to ask is, what is my general objective? So we will see some example in the next slide, but here the idea is that the objective at this step is quite general. Then we have another one which is more specific, that is, what is my task? So the objective is very general, but task is more specific. Then inside my task, what we want to solve, we have what is an example. What is the thing that we want to predict, or what is the main element that we want to study? Then another question is what is the expected outcome? So for each example, what output will be useful? What our system should provide as an output? Once we have defined that, one important question to ask is, what are the acceptable behaviors and what are the unacceptable behaviors? So here we can think of performance. It may be more of an intuition, like I want my task to achieve a certain performance. For example, an acceptable behavior can be that our system should be at least 90% accurate. Similarly, an unacceptable behavior can be of 80% or less. Think also in terms of security. So, computer security in terms of discrimination, privacy, and ethical issues. It's especially important to think about this because at a very early stage in order to design the whole life cycle accordingly. If we come up with this at the end of our model design, or we just discover that we have some issues at the later stage, we may lose more time. The later the stage of discovering the problem, the worse it will be. For example, and maybe we are familiar with this incident that happened with the automatic image recognition algorithm in Google, which classified the photo of a man with African ethnicity as a gorilla. So it is a clear case of ethical violation, and it can be really problematic if we discover this type of problem at a later stage when the model is already deployed, indicating that the bad, unacceptable behavior is already taking place. So let's discuss quickly some important points. So in terms of security, we have to think what can be the consequences if our machine learning model is facing an attacker. So think of spammers, for example. If we train a spam filtering model, maybe we have an attacker that will try to use different words, for example, using synonyms in order to evade the spam filter, or maybe voluntary misspelling some words to make the tags unrecognizable to the spam filtering model. And as an example, in the famous Viagra emails, a spammer can replace the alphabet I with a digit 1, or the alphabet A with a character at the rate, etc. If we talk about discrimination. An example of discrimination can be that a few years ago, to identify repeated felons or the probability that the person will repeat a felony that he or she has been convicted of in US, the jury members used to take the help of machine learning models provided by an organization. Later, it was found that the model predicted more chances of a person repeating the felony if he or she belongs to African ethnicity, which was highly discriminative. So, for people with different ethnicities, the model proposed the probability of repeating the crime differently depending on the color. Hence, a case of discrimination embedded in the machine learning model. So, we have to consider from the beginning what can be the unacceptable behavior in terms of discrimination. By the way, if you're interested to know more on the real world bias issues of machine learning, I recommend you to watch the documentary Coded Bias. It is also available on Netflix. If we talk about privacy, we have to think what will happen if my model is breached. Can people get unauthorized access to the training data inside my model? Many incidents show that we can get access to some of the training data. That means photos that were used to train a face recognition model if this model is breached. So, in this scenario, we can think that it can be a problem, especially for medical applications when we apply it to medical domain, because we want to ensure that the data that we have should not be leaked if we release our model. We also have to think about the sensitivity of the data that we have. If the data is very sensitive, we have to be extra careful and to put a lot of process in order to be sure that the data will be treated by respecting privacy. Um, Another concern is ethical issues. So if we are tackling, for example, some problem that we discussed before, the one about the jury relying on machine learning algorithm, it can be pretty problematic if the jury is influenced by a black box model that is not able to explain. Um, it doesn't mean that it's bad that there's a jury who is using some algorithm or some machine learning to make decision, but sometimes it's not necessarily good, either because we really have to think about what are the ethical issues associated with the problem that we can have by applying machine learning in our case. So coming back to the problem of what are the acceptable behavior and the one that are not acceptable, we may we may want to know how we can measure each of them. So what are the metrics that we can have to measure each acceptable and unacceptable behavior? If we are thinking of performance, we can consider the accuracy. For example, we can take some performance metric and say that if our accuracy is higher than 95%, it's good, it's acceptable behavior. And if it's lower than some threshold, it's bad. We can think of the discrimination. Also, we have different published papers. We have different metrics that exist to assess if our model is being discriminative against some people. We have also some matrix that and some methods to ensure privacy, security, etc. Lastly, once we did all that, we want to ask ourselves the question, do we have available data? Or if not, then can we build or gather it? It is written as lastly because it really has to be the last point that should be asked, because generally people rush to find the data set to see what they can do, but generally it's really better to think the other way around, and to think what is our task or our general objective that we want to achieve, and then go step by step in the order that was showed here, and not to rush the other way around. Now, let's try to understand with the help of an example. We will take the example of the spam filtering case. So, we need to ask ourselves that what is the objective in this case? Well, I am an email provider and I want to offer the best services possible to my user. So, this is my general objective. We see that it can be an objective of my project or my organization or company. The task here is to automatically detect spam. So, in order to provide this service to the user, and also to keep in mind that they are not annoyed by constant spamming. An example or an object of interest in this case is an email. So, what will be an output? What will be an input to the machine learning model is an email, and the output will be if it's a spam or not. An acceptable behavior, or we can say that if my model classify most of the spam as spam emails, then it's good. So we can measure the classification of the spam and can consider that an acceptable uh, probability of detecting a spam should be at least 75%. This is called sensitivity or recall. It is an important term used in machine learning very frequently. Recall or sensitivity in this case is equal to the number of spam that is detected by the model among the ones that are spams. Mathematically, in this case, recall is the percentage of spam emails correctly predicted as spam. We see this a lot in binary classifications. Sensitivity or recall, this is one metric. So, what are the type of unacceptable behavior that we can find? Well, first, in terms of performance, the spam filtering model can falsely classify only a few emails as spam that are really not spam, because so we do not want it to have too many mistakes. So we can measure this unacceptable behavior by their specificity. Specificity is a metric that also known as the true negative, and it corresponds to the amount of non-spam emails that will be classified as non-spams. So here it should be at least 95%. So that we don't push too much non-spam emails in the spam folder. So an important point here is that uh, we can have different levels of acceptable and unacceptable behavior, because here we have the specificity of 95%, meaning correctly predicting a non-spam email as non-spam, and sensitivity of 75, meaning correctly predicting spam as spam. We know that it's more harmful to classify a real email, that is a non-spam email, as a spam, rather than to falsely classifying a spam as a non-spam email. The reason can be that if an email is falsely classified as a spam, then the person will not be able to read it. It is obviously possible that one type of error is more problematic than the other. we can embed such a specification in some differentiated metrics. So performance achieved in different problems can be measured by different levels or thresholds. Another type of unacceptable behaviors can be related to security. In terms of security, a spammer should not be able to find an easy way to fool the spam filter. For example, as we discussed before, if the spammer replaces some alphabets that are very similar to the original one, and by doing so, he or she is able to fool the spam filtering model, then it's not good. What will be good is if the spam filter doesn't get fooled by the use of synonyms. If the spammer is changing or masking some words, then it should not change the output of the decision of the classifier. Um, in terms of privacy, maybe we do not want the email contacts to be leaked from the training model. Let's say we deployed our model, and if the model gets compromised in terms of accessibility to some other user, then we don't want this user to be able to read other users' emails or contents. There can be many unacceptable behaviors similar to these. Now let's try to know a thing or two about the cost that we should be considered or estimated. So at this step of in the goal definition, what can be good to do is a cost benefit analysis. So the general idea is that we need to analyze what is best, what is the benefit of deploying such a model, doing such a task in an automated way using machine learning, but to compare it with the cost. So we can compare it in to monetary values. For example, if we are in the industry, but what is the benefit, what is the money that will be brought by using such a model as a benefit, what money will be generated, and also the reverse, that is, what money would it be costing to invest. We can also think about that in terms of time taken. So, what is the time and cost that will be required to put in, and what will be the benefit gained? So, to estimate the cost, we have to consider some things. First, we have to consider the difficulty of the problem. For example, are there any existing libraries that allow us to train our model? If we have some existing library, then it will be a lot easier to find and train a good model rather than if we have to build it by hand. Hence, it's one of the questions that we have to ask. Also, we need to ask if we need to perform a lot of computation to train the model. This is basically estimating the complexity of the problem. For example, if our problem is spam filtering, then it's not an easy task, but it's not a very complicated task in comparison to other tasks, such as building models to assist in autonomous driving for self driving cars, a problem that is much more difficult. Another major thing to consider is the cost of data. Because we want to generate some data, it can be costly. We need to analyze if the data can be generated automatically. If it's the case, it will be probably a lot cheaper to gather some data. Another question is the cost of manual annotations. If we have to label our data, what is the cost associated to it? So we can think that if we have to label images and to say if it's a cat or a dog, is it's not the same cost as if we have to ask well qualified doctors to label X ray scans. So, because medical imaging is one of the applications of machine learning, where it is used to classify X ray scans. Let's say we have an X ray image of bone and we want to know if it is broken. We can have different types of application, but that is the underlying idea. If we have to pay a lot of doctors to label thousands of images, it will be a lot more costly than if we have to do simpler tasks. Also, we will need to think about how many examples do we need. This is related to the complexity of the problem. If we have a very complex task, we will need a lot of data. If we have a simple task, we will need less data and it will probably be a little cheaper. Also, one thing to have in mind is the accuracy that we need. So, the first question we ask is how costly is each wrong prediction? We already talked about that. If each wrong prediction is very costly, then we have to take that into account when we estimate the cost. As we discussed earlier in the spam example, the specificity and the recall were not problematic in the same way. Also, something to keep in mind is that what is the lowest accuracy level below which the model is impractical? This is related to the unacceptable behavior in terms of performance that we have seen before. Um, the idea is to define the minimum level of accuracy that is needed, because if the trained model performs too bad, then it will not be useful. One thing to consider is that the cost of performance increases exponentially to the increase in performance. Here is the figure to represent this idea that if we need an accuracy of 80%, it will be not too costly, but the cost becomes comparatively exponentially higher to achieve an accuracy of 90%. As we can observe in the beginning, that is to achieve a lower accuracy level, it doesn't cost a lot, but the cost to go from 99% to 99.9% is really very high. So the increase in cost will be much higher when we want to increase the accuracy. Now let's come back to the machine learning project life cycle. Okay, so now let's review the next step, that is data collection and data preparation. So this is closer to what we will do, and we will do that a lot, regardless if it's in the industry or in academia. And generally, it is a time consuming process. So let's talk about it in detail.